We've looked at these types of function questions before. Now we're just applying them to exponential functions. In question 1a, where we're asked to find the g of -1, we've changed x to -1. So we also need to change this x. Why don't you evaluate the g of -1? So you found 4 to the power of -1 minus 2. You found the reciprocal of 1 over 4 and then subtracted. Remember that 2 is equal to 8 over 4, and this was equal to -7 over 4. When we ask what point is on the graph, remember that x is -1, and we evaluated the g of x or y as -7 over 4. Question 1b is a little bit different. We're given a statement for the g of x. We're told it equals 62. Up here, we're told the g of x equals 4x minus 2. We know that the g of x equals the g of x, so we can let 62 equal 4 to the power of x minus 2. Why don't you solve this equation? When you simplified, you found that 4 to the power of x is 64, and we knew that 64 could be written as a power with base 4, and we found x equals 3. Our point on the graph then, x is 3, and the g of x, or y, is 62. Solve question 2, part A. So you did your substitution here and then found the reciprocal of 1/2. So you ended up with 2 to the power of 4. And finally, the m of x equals 14. So when x is -4, we know that the m of x, or y, is 14. Finish with part B here. I hope you were able to evaluate this one because it was a matter of remembering your negative exponents. We know that 32 is equal to 2 to the power of 5. And if we find the reciprocal of 2, our exponent became negative. X equals -5. When x is -5, y, or the m of x, is 30. In part C, I asked you to find the 0 of m. We talked about the zeros of a function when we were looking at polynomials. We said for the zeros of a function, we were finding the x-intercept or letting y equal 0. Or in this case, the m of x equals 0. Why don't you substitute 0 in for m of x and solve this function? After substituting, you should have found that solving this equation was the same as the one in part B. The next 3 equations always show up on tests and exams, and if I ask to verify with you, or if I ask to see your work, you're going to have had to practice. For some people, these are a little bit difficult. So let's go through them. We start with this equation, 4 to the power of x equals 13. And I know that I can't make a common base here. But I'm asked to find 4 to the power of -2x. We want to concentrate specifically on 4 to the power of x and 4 to the power of -2x. On the right, I can see I have multiplication. This is -2 times x. And I know that I multiply exponents when I raise a power to a power. That means that I could write this as 4 to the power exponent -2 all raised to x, or I could write it as 4 to the power of x raised to the power of -2. This is the one we like because I'm starting with 4 to the power of x. That's what I'm starting with here. 4 to the power of x equals 13. If I raise this to the power of -2, I need to raise this side to the power of -2. We talked about that at the beginning of this course when we said you have to do the same thing to both sides of your equation. If I simplify on the left, I get that 4 to the power of -2x. On the right, 13 to the power of -2, or 1 over 13 squared, which can, of course, be simplified. Let's look at question 4 together. We're looking at this first. So I have 25 to the power of x and 5 to the power of -x. Well, first of all, I see that I could write these with the same base. So the question is, how do I get from 5 to the power of 2x to 5 to the power of -x? I know if I multiply by -1/2, I would have 5 to the power of -x. So 25 to the power of x equals 81. I can write this as 5 to the power of 2x. And I raise this to the power of -1/2. If I do that on the left, I have to do that on the right. Multiplying my exponents on the left, 2 times -1/2 is -1, and then there's still x. And here I have 1 over the square root of 81, which equals 1/9. Why don't you give question 5 a try? So we're starting with 4 to the power of -3x. We want 4 to the power of x. So again, we're going to multiply, this time by -1/3. -3 times -1/3 will give me that 4 to the power of x. If I'm multiplying by -1/3 in my exponent, I know I'm raising this to the power of -1/3. I have to raise both sides to the power of -1/3. On the left, I'm left with 4 to the power of x. On the right, the cube root of 27, which equals 3. These take a lot of practice. I would strongly suggest you go to your e-text for the questions that you can find there and practice those. Use the solutions. Those can be found on the class Moodle page.